This is the second logic game from PrepTest 53. This is a basic sequencing game. We have G, J, L, M, P, and V, 6 variables that go into 6 slots, 1 through 6. Nothing too complex here. Each variable just goes into one of the positions. Our first rule is pretty basic. It just says that P has to be before M, and M has to be before L. So we find out here that P has at least 2 followers, M and L, which forces P out of both 5 and 6. So, for instance, we couldn't put P here in 5, right, because then there'd be no space to put both M and L. On the other hand, L has 2 leaders, P and M. So L can't go in either spaces 1 or 2 because we have to have room for P and M. M has 1 leader, P, and 1 follower, L, forcing M out of positions 1 and 6. Our second rule is a little more complex. This is that G is either before J or after L, but not both. So either G is before J or G is after L, but not both. So we could just leave the rule like this and just have to say, oh, one of these two, but not both of them have to be the case. But this isn't very practical. This isn't very useful for us. So what we want to do is we want to look at it and say, what's really going on in this game? What does this rule actually mean when I get to apply it? So let's think it through for a moment. If we have G before J, right, if we find out that G is in fact before J, the game could tell us that G is before J, we could find out that G is in position 1. That'd be enough to trigger this rule that G is before J. We could find out that J is in position 6. That'd be another way we could do it. There's a lot of ways that this could happen when we find out that G is before J. But if we do find that out, then what do we now know to be true? Well, we know that L is not before G. Well, what does that mean exactly for L not to be before G? Well, if L's not before G, right, then G must be before L. Because it's not like that we can put L and G together. It's not like we can have like L and G together on 2. That's not how the game works. This is a one-to-one kind of game. We have 6 variables going to 6 slots, and each slot has 1 variable. So if L is not before G, well, somebody has to be in front of someone. So if L is not before G, then G has to be before L. So we find out that G is before J. G must also be before L, and that's what this actually looks like. G before J actually looks like this down here, that G is before both J and L. So what about the other end of this? What happens if L is before G? Well, if we find out that L is before G, then what else must be true? Well, now we know that if L is before G, that G cannot be before J. Well, it's the same thing that we just did on the other end of it. If G is not before J, well, then J has to be before G. And this is the more practical version of this rule. We now know that G before J actually means G before J and L, and that L before G actually means L and J before G. And this is a lot easier for us to use. It's a lot easier for us to work with. And therefore, this is the way that we want to write the rule and the way that we want to be thinking about the rule as we go to the questions. Our third rule is very similar to our second rule. It says that V is either before G or after P, but not both. So either V is before G or V is after P, but not both. So this is the exact same situation that we were in with our previous rule. So we're going to treat it the exact same way. If V is before G, well, what do we know to be true now? If we find out that V is before G, well, we know now that P cannot be before V. This is no longer allowed, right? Because this scenario, V is before G, so this can't be true. So what happens if P is not before V? Well, in that situation, then V must be before P. And what if we find out that P is before V? Well, what must be true under that circumstance? If P is before V, well, now we know that V cannot be before G. It's not allowed. Therefore, G must be before V. And that's the same kind of rule that we had before, where V is either before both P and G, or V is after both P and G. And that's the way that we want to write it down. We want to write down as V before both G and P, or V after both G and P. And that's the easier way to be thinking about this rule as we work through the game. So the key to both of these is that we have a variable that cannot be sandwiched in between the other two. It can't be between the other two variables. In this case, we have G. G cannot be between both J and L. It has to be on one side or the other of both variables. And down here we have V, which has to be on the one side or the other of both G and P. Our first question is just an acceptability question, and we're just given a list of variables and asked which one of the following could be true. So we're just going to go rule by rule and eliminate answer choices that violate these rules. Our first rule says P has to be before M and M has to be before L. And that allows us to eliminate answer choice B, because answer choice B has P before L before M. And that, of course, is different than when our rule states the order should be. This also allows us to eliminate answer choice E, which has L before P before M. This, of course, is absolutely not acceptable given our first rule. Our second rule says that G has to be either on one side of J and L or the other, so it can never be sandwiched in between J and L. And that allows us to eliminate answer choice A. In answer choice A, we have that G is in between J and L. In fact, we have a situation where J is 1 and L is 6. So we can say with confidence here that G is in fact in between these two variables, and that, of course, is just not allowed according to Rule 2. And our final rule says that V cannot be sandwiched between G and P, and that's exactly what answer choice D does. D has V in between both G and P. We see in answer choice D that P is in position 1, V is in position 3, and G is in position 4. And this, of course, this is exactly what we're not allowed to do according to Rule 3. P and G have to be on one side of V or the other. V cannot be in between them, and therefore D is also incorrect. This leaves us with C as our right answer. Question number 2 is just a global question, and we're looking at M here, and we're saying M can't go on which of the following positions in our diagram. Well, just looking at Rule 1, we immediately see that M cannot go in position 1 or position 6 because M has one leader, P. So if we put M into 1, what would happen? Well, there'd be nowhere for P to go. What if we put M into position 6? Well, now there's nowhere for L to go because L has to come somewhere after M. So we know that M cannot go on 1 or 6. Just looking at Rule 1, just glancing at it, that should be obvious to us. And of course, answer choice A is position 6. Therefore, we know that that's our answer because that cannot be true. M cannot be in 6. Question 8 says that if L is in position 6, then what must be true? So let's put L into position 6 and kind of say, okay, so what must be true in this scenario? Well, first we'll look at Rule 1 and see, well, this really doesn't tell us much at all, right? Because L is, of course, is going to have to be after M. But in Rule 2, we do have something. We know that L cannot be before G. That's not allowed. We cannot have L before G because L is in the last place. L is in 6th, right? It's in the 6th position. So L cannot possibly be before G because where would G go? Which means that we know that G is going to be before L in some way. And if G is going to be before L, then we also know that G must be before J. And that is exactly what answer choice A tells us. Answer choice A is just saying, hey, it must be true that G is before J. And that absolutely has to be the case. And therefore, A is our answer. Question 9 says, if J is before M, if J is before M, then each of the following could be true except. In other words, we have a cannot be true question. If J is before M, then which one of the answer choices cannot be true? Well, we can just combine this with our P before M before L rule and see that now M has 2 leaders and M has 1 follower. J has 2 followers. L has 3 leaders. And this already gives us a better sense of what's going on in this scenario. And just using this, just looking at Rule 1 and combining it with the new information that we have, we're able to solve the question. Because if you look at answer choice D, it says that J is presented 5th. It says, so it's saying that J is in 5th in answer choice D. Well, that cannot be true because J now has both M and L after it, and there's just no room. J has 2 followers now. So D cannot be true, and therefore it is our answer choice. Now you might be saying, well, how did you get there so quickly? Why did you look at D? so fast. And the truth is that I didn't just immediately look at D. What we do here is that once we have at least a little bit of information, we just want to kind of scan through the answer choices and think to ourselves, okay, is there anything that I already know? Is there anything that I can just easily eliminate, or potentially just go ahead and just circle and move on? And in this case, D is right before us. If we understand how to quickly look at a sequencing chain and determine the leaders and the followers and know what that means, then we could easily look at D and just immediately know that that's our answer. And if you can't look at a chain, a sequencing chain, and immediately notice, oh, this is the number of leaders that a variable has, this is how many followers that a variable has, and I know what that means and how to apply it, then you're going to want to do a little more practice on sequencing and probably look at our sequencing lesson again to get a little more experience in that area. Question 10 says, which of the following cannot be first? So we want to know who cannot go in our first position. So once again, we're going to try to go for the easy win here and just look at our easy rule, look at rule 1 and say, well, who can't be in first? There are two options, both M and L. Neither one of them can go in first because both of them have a leader. So if we see either M or L on our list, then we immediately know that's the answer. We glance at our list and find that answer C. Yes, that's L. L cannot be in first because, of course, if L was in first, then where would P and M go? There's just nowhere for them to be, and therefore C is our answer. Question 11 is another acceptability question, but it's with a twist. We're not given a full list of possibilities. We're just given some of the positions. And we're supposed to go through this list and find the answer that could be true, which partial list of variables could be true. So let's look at each one. Answer A says that M is in first, L is in fourth, and G is in fifth. And the question is, could that be true? This is obviously wrong once we look at rule number 1, because where is P going to go? P has to come before M. And right now we have M in first. M, of course, has a leader and therefore is forced out of position 1, which is the other way to look at it. Either way, we know that A is wrong. Answer B says that G is in second, that P is in third, and that J is in fourth. So just glancing through our rules, I don't immediately see anything wrong with this, but I don't immediately see any rule violation. So let's test it out. Let's go through and see if we can infer anything else about the scenario. And my eyes first go to rule 1. Well, we have P on our diagram. We have P in position 3. So now we have to have M and L come after it in that order. Well, there's only space for them to do that in 5 and 6. So we know M's going to have to go in 5, L's going to have to go in 6, and that only leaves position 1 open for V. V can't go anywhere else now. So let's just go through our other two rules and see if the other two rules are followed. Is G either before J and L or after both J and L? And yes, it is. G is before J and G is before L. So rule number 1 and 2 both followed here because we have P before M before L and G is before J and L. So now we just have to find if it follows rule number 3. And if it does, then we found our answer choice. And as it turns out, yes, V is before both G and P. So we are following rule 3 and we found our answer. Another way of dealing with this question is just to go rule by rule and eliminate answer choices that violate each rule and just treat it like a normal acceptability question. So let's go through that process as well, just to see what it's like. So the first rule says P has to be before M, which has to be before L. And of course, as we've already seen, answer A violates that rule by putting M into position 1, and there's just no room for P. Answer D also violates this rule by putting P before L, P immediately before L, which leaves no room for M. Where is M going to go in answer D? Well, there's just nowhere for it to go, and therefore D is also wrong. Rule number 2 says that G either has to be before both J and L, or G has to be after both J and L. And we can see here that answer C violates that. G is before J, which means that G would also have to be before L, but there's no room for G to be before L, and therefore answer choice C violates that rule. Answer E does the exact same thing. Because G is before L, it also has to be before J, but there's no room for G to be before J, and therefore E is also wrong. And just using these first two rules, we can actually get down to answer choice B being the only remaining option for us, and therefore it must be our answer.